So shall we continue? So if anyone has any doubt regarding this mapping of the three-dimensional table into a data cube, then you can ask me. Is it clear to everyone? The mapping is clear to everyone? The mapping is very important. You have to
Yes.
understand this multidimensional
Yes,
concept.
yes.
Okay, thank you. Because you will have to write some basic queries on this multidimensional concept. Okay, you don't have a practical, but you have to know how to write a multidimensional query or OLAP queries. Okay, on the multidimensional data that I will show you. Now now we will make it more complex. Okay, a little bit more complex. From 3D view, we are going to support for the fourth dimensional view, 4D view. And obviously, for fourth dimensional, to create a fourth dimensional view on the existing data, we have to introduce one more dimension, and that dimension will be supplier. Okay, supplier. The dimension we have introduced here, this fourth dimension, that is called supplier. Okay, so if we continue in this way, that we may display any n dimensional data as a series of n-1 dimensional cube. Okay, so if we introduce a supplier dimension, so suppose this is a first data cube for supplier dimension 1. This is a second data cube for supplier dimension 2. This is a third data cube for supplier dimension 3. So all the previous 3 dimensions exist in each and every cube. Okay, time dimension, location dimension, and item type dimension for all an individual cube. As well as each and every cube represents its data based on a supplier, individual supplier. This cube represents data based on supplier 1. This cube represents data based on supplier 2, and this cube represents this data based on supplier 3, and so on. So these are 4-dimensional data cube representation, okay, of the sales data of that company or electronics based on those 4-dimension: item, type, location, and supplier. Okay, is it clear to everyone?
No,
Yes,
sir.
sir.
Now
Sir,
we
please
are,
repeat. Hello.
yes, yes, yes. So
Sir,
okay,
this
I'm
is
going to,
not clear to me.
okay, I am making that dimension, 3-dimensional view, into more complex. I'm converting it into more complex dimension, where we have attached one extra dimension to convert it into from 3-dimensional to 4-dimension view. Okay, 4D view, from 3D view to 4D view. So that's why we have introduced a fourth dimension, that is supplier dimension. Okay, so based on the supplier dimension, we divide the supplier dimension into different kind of supplier. So supplier 1, supplier 2, supplier 3, and supplier 4. Okay, so in this dimension, in this way, we have divide our data into different dimension based on supplier dimension. Okay, the supplier is the fourth dimension. Okay, now each and every supplier maintain a data cube of this 3 dimension: location dimension, time dimension, and item dimension. Each and every supplier. So supplier 1 will maintain a data cube of this 3 dimension: location, item, and time. Supplier 2 will maintain the same data cube for 3 dimension: item, time, and location. And supplier 3 will maintain the same dimension, same data cube for this 3 dimension: item, time, and location, and so on. If there are more than supplier 3, then number of cubes will be drawn. Same number of similar type of number of cubes will be drawn multiple amount of time. Okay, so this is a 4-dimensional view. Now the thing is that this 4-dimensional view cannot be represented in terms of tables. Table দিয়ে represent করা সম্ভব নয়, this 4-dimensional, because table is we actually drawing the table in a 2D plane. The paper is our 2D plane. So maximum 3-dimensional view can be supported by the help of table. So there is one very innovative way we can represent this 4-dimension with the help of lattice. Lattice. Okay, this is very, very interesting and very important. So 4-dimension we can represent in terms of lattice. This is 4D base cuboid, or base cuboid means the bottom cuboid, or the lowest cuboid part, and that will be represented in terms of lattice. I think all of you have some idea about the lattice, because in mathematics you have already learned about the lattice. Okay, lattice is nothing but a collection of nodes connected with defined relationship. Okay, so in this lattice, the lowest dimension, look at the lattice very carefully, starting from bottom to top. We will start from bottom and then we will gradually move to the top. Okay, so at the bottom there is a 4-dimensional base cuboid. That means all the 4 dimension has been mentioned: time, item, location, supplier. Please try to understand how we can draw this lattice that I am going to tell you here. Time, item, location, supplier. So these are the 4 dimensions we have. Just according to this 4-dimensional view, we'll have the 4 dimension as a base cuboid, right? Now from this is a node which will represent this 4 dimension. Now this will be divided into number of nodes. How many number of nodes will be divided? Because how many number of combination we can perform, a unique combination we can perform this 4 dimension, that number of nodes will be created in the next next level of the lattice. Okay, so the first combination, time, item, location, we can create. So time, item, location, we can create. The first combination. Second combination, item, location, supplier, we can create. Item, location, supplier, we can create. This one. This or this one. Item, location, supplier, we can create. Second dimension. Or you can say the second level of lattice. Third level of lattice, time, location, and supplier. Time, location, and supplier we will create. And the last location, last level of lattice is time, item, supply. So all types of combination, the maximum 4 combination is allowed based on this 4 dimension. So that 4 combination will represent by 4 different nodes of the lattice, and they are interconnected with each other. Okay, from the base with the base cuboid. So this is called 3D cuboid, 3-dimensional cuboid. Why 3 dimension? Because we have successfully divided the 4 dimension into a 3-dimension sets. These are the sets of 3 dimensions, 4 sets of 3 dimensions. That's why it is converted from 4D cuboid to 3D cuboid. Now we will move further. What is the further division? Further division tells that we can divide this in individual 3 dimension into two unique kind of dimension. That means 2 combinations of these 3 dimensions. So first combination is time and item. Second combination is time and location. Third combination is item and location. So maximum 3 combinations can be performed: time and item, time and location, and item and location. So in the same way, this can be also divided into 3 dimensions, and they are connected with each other. Okay, so in this way we can convert from 3 dimension to 2 dimension. Now again we will move further from 2 dimension to 1 dimension. We can convert. How? So it will be divided into 2 unique dimension. One is time dimension, and another one is item dimension. This will be divided again into 2 unique dimension. One is time dimension, and one is location dimension, because time dimension already exists. So that's why the mapping will be on the similar node. Okay. Then this time and supply will again divide into 2 unique dimension. One is time dimension, another one is supply dimension. So in this way, each and every dimensions, 2 dimension will be mapped into individual unique dimension. So in this way, we can convert the 2D cuboids into 1-dimensional cuboids. And the last and final dimension, that means we will add all these 4 dimensions together to make the top layer of the lattice, which is called apex cuboid or 0-dimensional cuboid. Do you understand how we can draw a lattice for the 4D-dimensional view?
Yes, sir.
Anyone has any doubt? Please tell me.
Yes, sir.
No
No, sir.
doubt, sir.
Is it clear to everyone? It's very important, because in examination we can
Yes, sir,
give
clear.
the question 4 dimension and how to draw a lattice from it. You have to draw accordingly. Okay, so you can draw it in the examination. But if there is more than 4 dimensions, suppose there's a 5 dimension, then it will be a little complex for this lattice. Okay, but up to 4 dimension, I think you can draw. But remember, please, 4 dimension or more than 4 dimensions, for 5 dimension, we are not able to represent those data, multidimensional data, more than 4 or 5 in the form of tables. Tables will be supported up to 3 dimensions. 3 dimensional basic into table আমরা draw করতে পারবো না. Okay, due to the limitations, because আমরা যেটা use করছি, যে তার উপর draw করছি, that is a page of 2D view. Okay, 2-dimensional page. Now come into the model. আজকে এটা দিয়ে শেষ করব. স্টার মডেল, স্নোফ্লেক মডেল, এন্ড ফার্স্ট কনস্টেলেশন স্কিমাস। অ্যাকচুয়ালি এগুলোকে মডেল বলা বা স্কিমাও বলা হয় ফর মাল্টি ডাইমেনশনাল ডেটাবেসেস। দিস 3 schema we are generally using for multi-dimensional databases. What are those 3 schema?
Sir, we have a class from 10.
Yes, 950. আমি একটা স্কিমা দেখিয়ে দিচ্ছি, তারপরে যদি সময় হয় তো দেখাবো, না ছেড়ে দেবো। ঠিক আছে? Okay, try to understand. So they are conceptual modeling or data warehouse. এই 3টে মডেল জেনারেলি ইউজ করা হয়। স্টার স্কিমা, মডেল বা স্কিমা তুমি যাই বলো। স্কিমা means what is schema? Schema is actually a definition of a model. তাই তো মনে পড়ছে? What is schema? Schema is nothing but a snapshot of a database design or a definition of a model, যেখানে আমরা ডেটাবেসের সব অ্যাট্রিবিউট নামগুলো দিতাম। মনে পড়ছে? How we can define a schema in RDBMS by using a create table, table name, then we have given the attributes them one by separated by commas. Okay, that is the RDBMS schema. But here we actually handle the multidimensional data with the help of these schemas: star schema, snowflake schema, and fast constellation schema. What is star schema? A fact table in the middle connected to a set of dimension table. So let's take the example of star schema. This is an example of star schema. খুব ভালো করে দেখো. In case of star schema, we can divide into two tables. সবকটারই দুটো করে টেবিল আছে. One is fact table and another is dimension table, which I already discussed. One is fact table and another one is dimension table. Now, fact table is generally a numerical measure which contains mainly two values, that is dollar sold or units sold. That means how many number of units sold and how much amount of dollars sold, that will be measured in terms of sales. So our fact table is generally a sales table is our fact table. Okay, and in case of star schema, the centralized table or the main table is the fact table. যেটাকে central table বলা হয় in that schema. Okay, তোমার নেটওয়ার্কিং কি পড়ছো বা এখন পড়েছো? তোমার নেটওয়ার্কিং এর স্টার টোপোলজি পড়েছো? Have you learned about the star topology in networking?
Sir,
Yes,
just
sir.
Yes, sir.
Sir,
Just
এইখানে
started.
sir.
পড়ার তো কথা, কারণ একদম প্রথম দিকে ওটা থাকে। তো স্টার টোপোলজি is generally working is very much similar. The model of the star topology is mapping with the star schema in this data warehousing. Similar model. So there is a centralized node and it will be connected with multiple sub nodes in star topology. Here the same thing. There is a centralized table which is called the fact table. Centralized table কিন্তু fact table ই হবে in case of star schema. There is only one fact table exists in a star schema, and here the fact table is a sales table, and the rest of the table are the dimension table. Rest of the tables are the dimension table. Okay, what are the dimension? চারটে dimension এক্ষুনি আমি তোমাকে বলেছি. Fourth dimension I have already shown in terms of lattice, in terms of data cubes. What are those dimensions? আমি দেখাচ্ছি item dimension, one dimension where assume here item dimension. This is another dimension, time dimension. This is another dimension, branch dimension, and this is fourth dimension, location dimension. So fourth dimension they have taken. Okay, in star schema model, in this model we have taken four dimension: item dimension, location dimension, branch dimension, and time dimension. So how many dimension table exist in this star schema? In this example, 4 dimension table. Clear? And how many fact table exist? Only one fact table exists whose name is sales table, which contains measures, numerical measures like units sold, dollars sold, average sale, these sort of things to measure the entire sales of a particular organization throughout the year. Okay. Now let's come into individual dimension table. So in the
Sir,
first,
what is measures here?
measures are numerical measures. Actually, how much sales you have done. একটা measure তো থাকে যে how much sales you have done, how many number of items have been sold from the organization in a particular year. That will be measured with the help of these units. Units sold, dollars sold, average sales. Understood? And that will be a
Okay, sir.
part of the fact table. Measures is always part of the fact table. Measure cannot be part of dimension table. Please remember it. Measures are always part of the fact table. And not
Okay,
only
sir.
measures, fact table also contains the primary key or candidate key of each and individual dimension table. Primary key কোনগুলো dimension table দেখি বলো তো? What are the primary key of item table? Item key, that is unique in nature. Location এর ক্ষেত্রে location key, that is also
Location
unique in
key.
nature. Branch এর
Branch
ক্ষেত্রে
key,
branch
time
key and time key. তো দেখো সেই কটা কি কিন্তু এখানে হোল্ড করে আছে fact table. কেন প্রাইমারি কি কে হোল্ড করছে? Because table ke joining korte gele you will need to join these tables with the help of primary key or candidate key. মনে পড়ছে? Normal join, তোমার natural join মনে পড়ছে?
Yes, sir. Yes,
Okay,
sir.
যারা ভুলে গেছে একটু রিভিশন দিয়ে নাও RDBMS টা, ঠিক আছে? So these are the dimension tables which will be connected in the form of stars. Okay, dimension table or fact table which will be connected in the form of stars. Okay, so this is a star schema model. Next, কারোর মাইক্রোফোনটা অন হয়েছে।
We need to join another class. We are
Okay,
the link.
okay, then we'll stop our lecture today here. Okay, and I'm going to take the attendance. Give me a couple of minutes, and from the next day onwards, next class onwards, we are going to discuss about the snowflake model and fast constellation model. and then we will go for other topics to discussion regarding the data warehouse. আর আমি সেই বুঝে তোমাকে তোমাদেরকে ডেটা ওয়্যারহাউসের ডেটা ক্লিনিং প্রসেসটাও পড়াবো, ঠিক আছে? Okay, I am just calling the names.